was. So, the quadratic formula, as we sang a second ago, is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And those letters come from a quadratic if it's written in standard form. Standard form means that everything's on one side and it equals 0. So the first step for the quadratic formula is exactly the same as the first step when you solve by factoring. You want it to equal 0. So ax squared plus bx plus c equals 0. Your a is the number in front of x squared. Your b is the number in front of x. Your c is the number that does not have a variable. Now, sometimes people try to take the x with it and plug it into the quadratic formula. Do you see any x's in here? No, because that's actually what we're solving for. So when you plug it in the quadratic formula, I should see no x's within the formula. Does that make sense? No x's. Okay, let's go ahead and write this. We're going to talk about the discriminant. Does anyone remember what that is? Discriminant. It's part of the quadratic formula. Yeah, you're close. It's the b squared minus 4ac. It's the part underneath the square root. So the discriminant is b squared minus 4ac. So if b squared minus 4ac equals 0, then that means the part underneath the square root zeroes out, right? And what's the square root of 0? 0. And so if you were to take this away, then you have negative b plus or minus 0. Adding and subtracting 0 accomplishes the exact same thing, right? You've added nothing to the number. So then we would cover that up, and our only answer would be negative b over 2a. So how many answers would we get? 1. Because if you add 0, subtract 0, you don't get different answers, you get the same answer. So anytime we have a discriminant of 0, we get one answer, and that answer is real because if you take a number and divide it by 2 times another number, that's still a number, right? You're allowed to do that. Okay, so we're going to say that this results in one real root. One real root. A root is another word for x-intercept. They often call them roots with a quadratic formula because we take square roots to get our answer. So they call them roots. But x-intercepts, zeros, roots, those are all talking about the same thing. Okay. Next, we could have b squared minus 4ac is greater than 0. It's a positive number. So if you have a positive number inside of a square root, then you're going to have negative b plus a legitimate number divided by something. That's going to give you one answer. And then negative b minus a legitimate number divided by 2 times another number is going to give you another answer. So this is going to result in 2 real roots. Two real roots. Now, with the 2 real roots, we have 2 options. You could have taken the square root of a perfect square, which would result in like a nice number. It could be written as a fraction. It could be written as a whole number maybe, but we call them rational numbers. So if you take the square root of a perfect square, you get a rational answer. Does that make sense? Okay, so we're going to say for this one, 2 options. If it's a perfect square, that gives you rational roots. If it is not a perfect square, you still get 2 answers, but they're nasty decimals. And they're decimals that cannot be written as fractions. You have to write them as a decimal. You have to round them. You have no other option. Does anyone know what we call these? Irrational. They're crazy numbers. They're irrational. Get it? All right. I tried. Irrational. Irrational roots. Okay. So if the discriminant equals 0, you've got one answer. If the discriminant is positive, you've got 2 answers. If the discriminant is negative, that means you're taking the square root of a negative number. And what happens when you take the square root of a negative number? It becomes imaginary. So we're going to say you still have 2 answers, but they're fake. So that's cool. We say 2 imaginary complex roots, because we all know those people who are kind of fake and they're very complex, right? People who are fake or complex? Hard to read them? Hard to figure it out? No? Okay. I'm trying to help you remember. So you'll be like, oh, fake roots, fake people, complex. You know what I'm saying? Yeah, it's like, yeah. Okay, so the word complex in math means that part of the number is real and part of the number is imaginary. So when you look at a complex root, or an imaginary answer in this case, the imaginary part is the part that's underneath the square root, but the negative b and the 2a are still real. So it's going to have part of it, the answer that's okay, and then part of the answer that's fake. But when we look at a graph, we're going to be like, oh yeah, those are answers, but it doesn't cross the x-axis. Because all these roots are x-intercepts. So if you have an imaginary root, that means that when you graph it, it's not going to cross the x-axis. Make sense? Ish? Kind of? Looks like it. Let's move on. Okay, so we're going to practice some of these. Yes, definitely calculator time. So if you need to go grab a calculator and trade me a cell phone, go ahead and do that. So we've got 3k squared plus 2k minus equals negative 3. And what do we have to do first? Add the 3, right? Make it equal 0. Okay. So 3k squared plus 2k plus 3 equals 0. And then this is our A, this is our B, this is our C. All right, so how do I start? Negative b, so I'm going to say x equals negative b plus or minus square root, yeah, b squared, 2 squared, or you can write 4, that's fine, minus 4 times a times c. You can say 4 times 9 if you want. So 4 times a times c. All divided by 2 times 3, 2 times a, which is 6. Okay. So here's what I'm going to ask you to do first. Because we have discriminants that could be negative, I don't want you to plug this all in at once, because then you're going to get error messages half the time. You're going to be like, why is it always giving me an error message? And it's doing that because you're getting a negative underneath your square root. So first thing, we're going to figure out what our discriminant equals. Ooh, look at that bright yellow. I'm moving the paper back and forth to make it dry. Think it's working? Probably. Okay, so in our calculator, let's go ahead and just plug in the discriminant. So 2 squared minus 4 times 3 times 3. And what are you guys getting for the discriminant? Negative 32. Okay, so I've got negative 2 plus or minus the square root of negative 32, all divided by 6. Okay. Anytime I see a negative underneath a square root, do you guys remember what we do? Yes. Yeah, so I make it a positive and I say this answer is imaginary. It's not the language. I am math. I'm hurt. I feel hurt. All right, so x equals, we have two solutions. -2 plus I root 32 over 6. -2 minus I root 32 over 6. Ms. Rice, do I have to write them as two different answers? No. I just want to make sure that you know there's two different answers. So you can write it like this, or you can write it like that. Ms. Rice, what happens if I leave the negative with the 32 and I do not put an I? Well, then you've killed a unicorn. Ugh, rough. Okay. Ready for the next problem?
So is it like illegal to write a negative under the square root?
It is illegal. You have to put the I. And so this is our answer. And we don't go any further, we just leave it there. You can write both of them, or you can write it like one answer. As long as you know that it's technically two answers when you write it like this. The plus minus implies that there's two answers. Okay. All right, the next example. Yes.
How do you make this answer?
That is as easy as this one really gets. Well, we can, if you wanted to reduce the square root, we could do that. But honestly, it's okay like this too. Shall we reduce the square root? You look uncomfortable.
Well, I'm just wondering if I can use slide and divide for that problem.
No. If it has an imaginary answer, that means it's not factorable. Because answers that can be factored have actual solutions. They have actual x-intercepts, right? That's what the solutions are that you get. So anytime we get an I as an answer, this problem could only possibly be solved by using the quadratic formula. If you had tried to factor it, it wouldn't work. So, and the reason is here you would have been trying to multiply to 9, but add to 2. And there's no numbers that are going to multiply to 9 but add to 2. Does that make sense? So sometimes, like the problems that we did all the factoring with, all of those can be solved with a quadratic formula. But this one could not have been factored. So every problem you can ever think of, you can always use the quadratic formula on for a quadratic. However, not every problem that can be solved with a quadratic formula can also be factored. Anything with an I is not factorable. Yeah. All right, second example. 4m squared plus 5 equals 4m. All right, what do I do first? Subtract the 4m. Okay, so I have 4m squared minus 4m plus 5 equals 0. So there's my A, there's my B, there's my C. Okay. So, you know what's funny? Last time I wrote x equals, what should I have written? K equals. Didn't even notice we used a different variable. Okay. So this time, instead of saying x equals, we're going to say m equals. Okay. How do I start the problem? Yeah, so it's negative b, and negative of negative 4 is positive 4. Okay. So negative of negative 4 is positive 4. Plus or minus the square root, 16, or you can say negative 4 squared. Now this is where we have to watch out for baby otters. Because they are. Look at the baby otter. If you come up and look at the picture later, the little baby otter is smiling. It's adorable. When you square a negative number, you have to put it in parentheses to show that you are squaring the negative with the number. Because we all know that a number times itself has to be positive. A negative times a negative is positive. But so many students, when they type this in, they'd be like, oh yeah, that's negative 16, totally. Because many students would type negative 4 squared. And if you type it like that, your calculator squares the 4, but it does not square the negative. So if you want to square negative 4, you have to type it in parentheses and then square it. Okay? So the first way, that kills a baby otter. The second way keeps it alive. It's utterly fantastic. I got that from Dr. Davis. If you guys didn't know, otters are her favorite animal, and she will tell you lots. And she has lots of otter puns. Very good ones. That's fair. My mom lied to my brother and I, and she put bananas in the freezer and called those dessert. And we loved them. They were popsicles. And then as an adult, I was like, that's just fruit. That's not dessert, that's fruit. She lied to us.
Well, I mean,
No, it was just a frozen banana.
it's supposed to be candy.
I mean, but it's not a replacement for a candy bar. She'd be like, would you like an otter pop or would you like a frozen banana? And we'd be like, frozen banana. I know, I feel so lied to. Okay, negative b, plus or minus b squared minus 4 times 4 times 5. Okay, all divided by 2 times 4. Marvelous. Okay, what are we going to type in first? Say it again. You could just take the number and square it. It wouldn't. Yeah. Your teacher did that to avoid that common mistake, which was smart of them. Yeah. If you just think of it as 4 and square 4 and get 16, you're good. Yeah. Oh, hello. What's up? Marvelous. You can give the tour, but I'm going to keep teaching so we can get through our lesson. Okay, marvelous. All right, so we're typing in the discriminant. We got negative 4 squared. Go ahead and type it. Make sure you're typing it. Minus 4 times A times C, and tell me what you get for your discriminant. 80? Negative 64. All right, so let's write what we have. We got 4 plus or minus the square root of negative 64. And what's it divided by? 8. Okay, so what do we do with that negative? We make it an I. And you have a perfect square, so it would be 8i. So I'm going to rewrite this as 4 plus or minus 8i divided by 8. You can leave it. Kind of. Yeah, you can actually think of it that way. So what we're going to do next, question. Kind of, yeah. So we're going to look at all 3 of the numbers, and we're going to say, based on all 3 of those numbers, what can I divide out of them? 4. So 4 divided by 4 is, 8 divided by 4 is, 8 divided by 4 is 2. So we've got 1 plus 2i divided by 2, 1 minus 2i divided by 2. Kind of. We factored the same number out of everything. We said as long as I can reduce them all by the same thing, then I'm good. Yes?
Can you leave it like the 4 plus and minus I squared is 64?
You should not. You should recognize that's a perfect square. Yeah. All right. Now, Emma asked if we could say this is 1/2 plus I. Could we? Yeah, it's the same thing. Because divide by 2, divide by 2. So this is just the option if you're not scared of fractions. That's a good option. They're both good. Okay. let's go ahead and do one more because I want to make you plug some in your calculator all the way through. So for this one, we're going to do 11k squared equals 17. Yeah. Seems like there's not enough in this problem. It's kind of a weird problem. You can always put a 0 in. Okay, so what should we make it equal first? 0. How are we going to do that? Okay, so 11k squared, I'm going to leave a space, and then I'm going to write negative 17 equals 0. Because I have an A term and I have a C term, but I do not have a B. So what I'm going to write for B is plus 0k. And that way I have an A, a B, and a C. Okay. But I beat ya. Miss Rice 1, Cameron 0. Oh, 0. All right, so this is A, this is B, this is C.
Ew, that's so not.
And we get K equals negative 0 or 0, which is the same thing, right? Okay. Negative B plus or minus 0 squared, which is 0, minus 4 times 11 times, you're close, negative 17, perfect, divided by 2 times
Wait, 0?
2 times 11. Okay, and then let's go ahead and figure out what our discriminant is. $748. Okay, you guys ready to type this in?
No.
Yes. The one thing I love about these updated calculators is that if you can do the alpha y equals to get that fraction on your screen, alpha y equals, you can type this problem in exactly the way it looks. So I've got alpha y equals, I've got my fraction. I'm just going to type 0 plus square root. Everyone know how to get the square root on there? Alpha y equals. Alpha y equals. Yes. 0 plus square root 748 divided by 22. Ta-da! Okay. K, squiggly equal sign. Why am I doing a squiggly equal sign? It's not exactly this answer. It's approximately this answer because I cut off numbers. So my answer is mostly good, but not completely perfect. I rounded. Okay. Now I'm going to do up arrow. I'm going to go back up to this one and grab it and press enter. And I'm just going to go through and change that to a minus sign. Please, nobody ask me where the plus minus button is. There's no plus minus. You have to do it twice. Once with plus, once with minus. If you ask me about a plus minus button, I will laugh at you. It'll be like, bah! What's a silly question? Yeah. All right.
So now who's Dad Vicky?
They walked past with Dr. Dre, and then they walked past when I was doing an evil laugh. Like shaking my head.
Our school has class, and
Now, is it always the case that the two answers are just like the positive and negative version of each other? No. The only reason that happened is because of the 0 in the front.
We got lucky.
We got lucky that time. The rest of the time, it'll be a different number.
All right.
Yes. All right. Are we feeling refreshed on the quadratic formula? Marvelous. Okay. So, I like how as you do the math, Snoop is looking at you. You can like he's staring at you. And he's making a very appropriate sign with his hand. All right, so what should I do first on number 1? Actually, before we even get started, I need everyone to write a color next to number 1. Just like write any color. But maybe don't say like cyan, because is that blue? I don't just say blue. Don't be like weird about it.
Burgundy red.
All right. So mine's going to be pink. All right. Now what do I do?
Me too. And I subtract 6.
2x squared plus 9x minus 18. I paused for a real long time on that, and it was a sincere pause because I'm really bad at 9s and 11s. You know, they're hard when you subtract 9s and 11s. Those are the two. I always get them mixed up when I actually... Anyway, 18. Okay. So, here's our A, here's our B, here's our C. So, x equals, then what do we have? -9 plus or minus. Okay, now this part, are you guys okay with us shortcutting this a little bit? Instead of writing the discriminant, I'm just going to type it in my calculator. Are you okay with that? So 9 squared minus 4 times A times C. And so my discriminant is 225. Is that a perfect square? Yes. All right, divided by 2 times 2a, which is 2 times 2, which is 4. Okay. Square root of 225 is 15, so I've got alpha y equals -9 plus 15. So square root of 225 is 15, so I've got -9 plus 15 over 4, 3/2.
Wait, hold on. My brain just stopped working. How do I do the fraction?
Alpha y equals.
I was doing alpha plus. I was like...
And then I'm going to go up and highlight it and press equals, bring it back down, change it to a minus. -6. Okay. And then I'm going to look at the back page and look for those answers. 3/2, -6. E. Okay. So number 1 goes with E. And so that means that Snoop has pink sneakers for me. What color sneakers do you guys have? Red sneakers?
Red.
What color did you have?
Red.
Red sneakers? Did everyone use red? Blue sneakers? Blue sneakers? All right. So, Miss Rice, I don't feel like doing math. I'm just going to color Snoop. No. Okay. So you can do math and then take a break to color, and then do math and take a break to color, and do math and take a break to color. Or you can do all the math and then do all the coloring. Or you can be like boring Bruno and not color at all. Yeah. You don't have to color. If you want to be a boring Bruno.
Okay, I just want to do all the math and then color so that it looks good.
I guess.
I mean, we can't have them trashy.
I mean, but the bad coloring is the amusing part. If you want to make Snoop look like a real person with not orange skin, that's fine, I guess, or green skin, or whatever. This is what we've got 15 minutes. So what we're going to try to do is about 5 problems.
There's a back.
We're going to do 5 problems for now. You do have you have a video tonight, so you're going to do 5 problems for now, and then we'll probably do some more problems tomorrow. You don't have to finish all of them. You're just going to do 5. So if you do 2 in class, then you have to do 3. Yes.
That is a jawline.